Here's a tutorial to show you how to distinguish between the two hypotheses we came up last lecture. Last lecture we were asking where the toxicity of the pathogenic strain of E. coli came from. Was it a mutation in an already existing gene in a non-pathogenic strain, or was it due to horizontal gene transfer? What we want to do is see if there's anything like a Sheikah toxin already present in a non-pathogenic strain, and also see if it's also located in the pathogenic one. How did we figure out it was a Sheikah toxin? We did a simple Google search, and by reading through several pages, it became apparent that the pathogenic strain we were looking for, that it causes the bloody diarrhea associated with hamburger disease, is the O157H7 strain. Now we want to go to img.jgi.doe.gov, and we have a few different tools we can use. The one we want to look at is the Integrated Microbial Genomes resource. This is the encyclopedia of different genomes. We want to look through all the ones that are available to see what's to see whether or not we can find that Sheikah toxin in there. So we can start out by going to the Find Genes section, and we can search for the name of the gene we're interested in. We want to look for Sheikah toxin. There we go. Lots of different strains of E. coli. Here's a B strain, so I'm just going to go hold my Command key or Control key down. Depends if you're a PC. If you're a Mac user, it's Command key. Otherwise, you can hold your Control key. And then click on all the different ones you want to get. So I'm releasing the Control key. K12 is non-pathogenic, so I'm going to choose all the K12 strains. If I scroll up, I still have that other one located. And that's it for K strains. Now let's look at pathogenic strains. Here's one. I want all of these pathogenic versions to see if I can find Sheikah toxin located in there. These were all independently isolated and sequenced from various infection sites. Okay, so now we have them. Now we want to look for the Sheikah toxin, so I'm going to click on that and see what will come out. And it transfers. And that was a lot faster because I reduced the number of genomes. So there's a lot of these Sheikah toxins that have been identified, quite a few. But look what we have over here in the organism name. We can see of all those different strains I chose, they're found only in the O157H7 versions of these. This is good evidence that this is a pathogen found only in the pathogenic strain. We can go into the object ID and get some information about that toxin, just like we did right here. Looking through, I think we can see, there's the DNA coordinates. I'll just highlight here. The DNA coordinates is the line we want to look at, and it tells where in the genome we found it. It's on the plus strain at this location. It's about 1,200,000 nucleotides in, and it's 960 base pairs. So by clicking on this, it will give me the genetic sequence for the Sheikah toxin. This is only subunit A, but there's a subunit B you could look at. And I'm going to grab this. Notice we've got a nice ORF here. We've got a first codon there. ATG is going to be the partner strand, not the template strand, but the partner strand, and that would code for AUG in the mRNA, all the way to UAA, which is the stop codon. So let's search through E. coli to see if we can find it using a BLAST search. So I'm going to go over here to BLAST. I'll post my sequence right in there. Again, we have to be careful to choose the E. coli we're interested in. And let's look for the non-pathogenic strains. Escherichia coli B strain, so Command key I'm holding down there. Let's look at our K12 strains. And let's see if there's anything resembling this over there. And there we have it. So we blasted here and saw nothing. Look over here, saw nothing. Look over here, really there's nothing. So this is showing us there's no nucleic acid associated with that particular gene, so we're having a hard time saying that it would have been a mutated version in a non-pathogenic strain. Can I go back a few of these? All right, let's go back to our list of all of these toxins. Remember these guys? So I just hit my back key a little bit. And now we can send some of these genes to our gene cart and do some exploration. So we've got two subunits here. Let's just stick to subunit B for a little bit, and I'll choose Sakai version, and do we have a subunit B here in a different strain? I'll choose this one over here, subunit B, and we'll choose another subunit B over here. These look like they're different strains, so let's put them in our gene cart. We can search in the neighborhoods. What the computer right now is doing is loading these in. Now it's sorted them, it's putting them together. Excellent, we're in. And now we can see these are the genomes that we're interested in looking at, specifically these parts for the subunit B for the Sheikah toxin. Oh, it looks like I got two different kinds of toxins here. I'd be surprised if this would show up. And if you scroll down, we can look in the neighborhood, look in the gene neighborhood, lining the genetic sequences up. So if we click on Show Neighborhoods, it's going to show us the ORFs in those regions, and the Sheikah toxin, I think, is this red guy right here. Yeah, see how I highlight over that? Toxin A, toxin 1, toxin 2. Yeah, we didn't get toxin 1 showing up on here, which doesn't surprise me. Toxin 2. Well, there's toxin 1. And if you notice, we've got these other regions right behind it of different types of proteins. What's this big one? A hypothetical protein, 6N48 amino acids, 6N45 amino acids for hypothetical protein. This hasn't been characterized yet. Now we can see a bacteriophage located there at 6N45. So we have some very similar sizes in these, and we can start to annotate. There's a putative endolysin. So notice that these endolysin and lysozyme sound very similar. I bet you they're the same thing. We can see some similarities between these different parts. So we would call this a synteny that demonstrates that there's similarity of these different O157H7 strains.